Download this code from codegive.com, link in the description below. The Guide to Preventing and Escaping Coding's Dreaded Infinite Loop. Infinite loops are the bane of every programmer's existence. They're the digital equivalent of a hamster on a wheel, seemingly endless, consuming resources, and ultimately unproductive. This comprehensive tutorial will equip you with the knowledge and strategies to prevent and escape these frustrating coding nightmares. We'll explore the root causes, practical prevention techniques, and effective escape strategies across several programming languages. Part 1: Understanding the Infinite Loop Beast. An infinite loop occurs when a loop's termination condition is never met. The loop continues executing indefinitely, potentially freezing your program, consuming all available CPU resources, and ultimately leading to a system crash. This typically happens due to errors in the loop's logic. Common causes *. 1. Incorrect loop condition *. The most frequent cause. A condition that's always true, example while true, or a condition that never becomes false due to a logic error within the loop. 2. Off by 1 errors *. These occur when the loop counter is incremented or decremented incorrectly, causing the loop to either run one iteration too many or too few, potentially creating an infinite loop if it misses the intended termination point. 3. Incorrect variable updates *. If a variable used in the loop condition isn't updated within the loop body, the condition will always remain true. 4. Unintentional recursion *. Recursive functions, which call themselves, can easily create infinite loops if the base case, the condition that stops the recursion, is missing or incorrectly defined. Part 2: Prevention Strategies, Proactive Defense. Preventing infinite loops is far better than dealing with them after they occur. Here's how. 1. Careful loop condition design *. Before writing your loop, clearly define the termination condition. Ask yourself, what are the conditions that should cause the loop to stop? How will those conditions be checked? What variables will be used to track progress and trigger termination? 2. Thorough testing of loop conditions *. Test your loop conditions with various inputs to ensure they work correctly in all scenarios, including edge cases and boundary conditions. 3. Code reviews and pair programming *. Have another programmer review your code, especially loop structures. A fresh pair of eyes can often spot subtle errors you've overlooked. 4. Defensive programming * include extra checks within your loop to detect potential problems. For example, if you expect a variable to be within a certain range, add a check to ensure this is the case. Part 3: Escaping the loop, reactive measures. If an infinite loop does occur, you need strategies to escape it without resorting to a hard reset. 1. Keyboard interrupt. Ctrl+C. Most operating systems and interactive environments, like Python's interpreter or a terminal, allow you to interrupt a running program using Ctrl+C, or CMD+C on Mac OS. This sends an interrupt signal to the program, usually forcing it to terminate. 2. Programmatic breakpoints/debugging * Use a debugger, built into IDEs like VS Code, Eclipse, or PyCharm, to step through your code line by line. Set breakpoints at strategic locations within your loop to examine variable values and identify the source of the problem. 3. Break statement * in languages like C, C++, Java, JavaScript, Python, etc. The break statement allows you to exit a loop prematurely. You can use this within a conditional statement to escape when a specific condition is met. Code examples: Python. Example of an infinite loop, and how to fix it. Part 4: Language-specific considerations *. While the principles remain the same across languages, Certain language features might offer additional escape mechanisms or introduce unique ways an infinite loop can arise. For example, in languages with concurrency, like Java or Go, improper synchronization can lead to deadlocks, a form of infinite loop where multiple threads are blocked waiting for each other. Conclusion *. Infinite loops are a serious problem, but with careful planning, thorough testing, and effective debugging techniques, you can significantly reduce their occurrence. By understanding their causes and mastering the strategies for both prevention and escape, you can significantly enhance your coding efficiency and reduce frustration. Remember, proactive prevention is always the best approach.